Hello everyone, my name is Tolga Karali. I'm doing my PhD in 19 Mayıs University, Department of Biochemistry in Samsun in Turkey. And today I'm going to present my poster about osteopontin, a therapeutic candidate for neurodegenerative diseases. Osteopontin is a multifunctional protein that is expressed and secreted in many cell types and plays a role in cell adhesion, invasion, migration, chemotaxis, prevention of apoptosis, and encourage independent growth of tumor cells. And you can see primary structure and post-translational modification of osteopontin in figure 1. And then I'm going to talk about functions of osteopontin. Osteopontin has received increasing attention due to its role in the pathophysiology of several degenerative, autoimmune, inflammatory diseases and cancer. Modular structural motifs in osteopontin that provide interaction surface for integrin and CD44 variant receptors elicit signal transduction, cytokine and chemokine effects. You can see here the role of osteopontin in immune cells, focusing on the relationship between inflammation and apoptosis in figure 2. Osteopontin plays a role in mediating the crosstalk between innate and adaptive immune response. Soluble osteopontin acts on macrophages, upregulating interleukin-12 production and thereby mediating T helper development. Additionally, it exerts an effect on T helper cells, stimulating the generation of interleukin-17 and curbing the release of interleukin-10, thereby promoting Th17 polarization. In conventional dendritic cells, intracellular osteopontin has been observed to inhibit interleukin 27 expression while simultaneously enhancing the response of Th17 cells. Plasmacytoid DC enhancing interferon alpha expression. Intercellular osteopontin plays a pivotal role in T follicular helper cells, as evidenced by its translocation into the nucleus during activation, which sustains TFH polarization. The thick and thin arrows indicate the production and actions of osteopontin respectively. And you can see the role of osteopontin in the crosstalk between innate and adaptive immunity in figure 3. In addition to its pro-inflammatory and pro-atherogenic functions, osteopontin is a potent physiological inhibitor of mineralization. Osteopontin is accepted as a potential biomarker in cardiovascular and central nervous system diseases and cancer. Osteopontin is a powerful sensor that responds to acute or cumulative damage that disrupt homeostasis in inflammatory neurodegenerative disorders. Recent studies have demonstrated that osteopontin promotes tissue damage and the repair mechanism triggered by the inflammatory response. The disparate effects observed attributed, at least in part, to the presence of distinct functional domains within the osteopontin molecule that become accessible following cleavage by thrombin or metalloproteases. Elevated plasma and cerebrospinal fluid osteopontin levels have been observed in individuals with multiple sclerosis and Alzheimer's disease, as well as in their respective experimental models. Under normal conditions, osteopontin expression levels are low in the brain. However, osteopontin expression is significantly increased in macrophage, microglia, and astrocytes in Parkinson's disease, hypoxia, ischemia, brain injury, Alzheimer's disease, and multiple sclerosis, demonstrating a neuroprotective effect. And you can see some neuroprotective signaling pathways inducing by osteopontin following acute brain injury in figure 4. In conclusion, osteopontin plays a role in maintaining homeostasis in the central nervous system by facilitating the recruitment of immune cells via tissue level signals and by regulating pro-inflammatory signaling via glial neuronal interactions, thereby providing neural protection. A deeper understanding of the molecular signaling pathways involved in osteopontin exerting its neuroprotective effect will contribute to developing osteopontin as a potential therapeutic target in treating neurodegenerative diseases. Thank you for listening to me.